Hello and welcome to our lesson number 5 of our NVIDIA Omniverse basic training. And in today's lesson, we are going to learn how do we generate synthetic data using NVIDIA Omniverse. Before doing our hands-on practice, we need to understand a few concepts. One of them is perception from the robotics and AI perspective. This is how our model sees the world, and we will concentrate in a few features of that perception that we need to leverage to train our model. We will learn about what means domain randomization and a few techniques for randomization that we can use in Omniverse thanks to Replicator and Randomizer, which are two extensions in Omniverse. So we have an out-of-the-box tool to randomize our environment and create a lot of different situations and lighting, etc. We'll see about that. And finally, we will see how we do that in Omniverse. Okay, so let's go for it. Okay, so first of all, let's go and define what we mean by perception. As I said, perception is everything that surrounds our robot or our model. And traditional perception was more generic in the sense that we were perceiving the whole surroundings, but now we are using what we call task-directed perception, which means we want to identify specific objects or specific actions in this environment. This will allow us to retrieve data from our environment, and we can apply our logic to this information that we are receiving. Thanks to that, our perception model will become the eyes and ears of our robot, and we will make our robot smarter or smart. And then our robot will use this model to predict motion, to select specific paths, avoid collisions. And why we use Omniverse? So here's where Replicator and Randomizer became very handy, because we can generate thousands of different situations in our digital twin, and that will make our robot to see the same item with different lightings, different backgrounds, or different weather, or different lighting in our warehouse, etc. And this is very important because this is something that we could not do in real life, in the sense that we have only so much time and so much different situations to train our model. Imagine to generate thousands of different situations in minutes. And once we have generated all that synthetic data, which is generating multiple different environments, we can fine-tune our model, and this is reinforcement learning, and then we will deploy this model into our real robot, or we can also test it in our digital twin with real photos of the real world. I will be sharing a few links. Let me find. Yes, so we have this NVIDIA documentation. Here you will see a few of the sensors that are available in Omniverse, and also a few extensions all related for perception. So how do we use, how we retrieve data from our environment within Omniverse? We have already done some practice with that because we have created a few robots in ISACSIM, adding sensors to them. Even if here it says the version for this documentation is 4.2, it's still valid for ISACSIM 4.5. Then here we have a blog which is very interesting and how we have used Omniverse and train our model to identify palette position. Okay, I recommend that you have a look to this blog. It's a pretty clear use case. Then we have the documentation for randomizer in Omniverse. How do we use randomizer? And also because we will be creating our synthetic data from code. And here you have a few examples of a few bits of the code that we use to randomize different elements within the Omniverse application. And here we have the documentation about Replicator. Okay, and how do we generate the synthetic data using Replicator. So in Omniverse, we will be using randomizer to generate multiple different situations and Replicator to generate the synthetic data. And let's go back to the PowerPoint. When we are training our perception model, we need to focus in 6 main tasks. So we need to focus in the object detection. So we need to make our robot to understand what is what. And you will see that in our cameras with a box surrounding the items that we want to focus on, and we can add labels to these items. Then we go a step further and we divide each object in different sections to understand each section within the object. Thanks to that, we can identify the size of the object, we can identify the orientation of the object and where this object is situated in our map, in our world. Then we identify where we are. This is which are our coordinates within the world that we are drawing. And this is us drawing, this is our robot drawing the world. So we are, thanks to the sensors, we are reconstructing a 3D scene of our surroundings, of what we are seeing, and then we are mapping our robot on it. And finally, we need to make the robot to understand the distance between objects. Okay? And just a couple more of the slides before we start with the hands-on. So first we need to understand why we need to fine-tune. We have pre-trained models which are very useful and they have been trained in huge amount of data, but they have not been trained in our specific environment, in our factory or our warehouse. So what we do is to use these pre-trained models. We add to these models our specific conditions, which will be our synthetic data, and then we fine-tune the model. For example, we add here this apple here, right? This will save a lot of time and resources because it's much more quicker. If you train your model from scratch, it's going to take a huge amount of time and resources. you can collect real world data from cameras or videos, but they will take time and that will be very limited. So that's why we use NVIDIA Omniverse to create this real world like data. Thanks to that synthetic data, our models will become much more accurate and much more smarter. We have already talked about that. And this is one example of why we would like to train this model. This example, and you have also the blog that I was sharing a couple of minutes ago. And now a quick introduction to domain randomization. So this is what we do in Omniverse using Replicator and Randomizer. These are just a few examples of things that we can randomize in Omniverse. And yeah, thanks to that, we make our model to behave like in the real world. And just to mention the three main techniques of randomizer. So first is the object itself. So we change the color, the texture, or the size of the object that we want to identify in our environment. Then we change the different lighting and point of views of the camera. And finally, we modify the background, the walls, the flooring, elements around our objects, the object that we want to identify. And that's all we need to know. So with that, we can go straight to the lab. Let's see how we do that using Omniverse. Okay, so the first thing we are going to do is to download this repository. This repository is a synthetic data generation with some ready assets. Here you have the guide and how to run this workflow locally. This is what we will be doing. This repository is to generate synthetic data to identify positions and where we see a pallet jack. This is a pallet jack. Okay. We will use domain randomizer with Replicator. We will generate the data in Kitty format. So it's a format to identify different points of the object that we want to train our model for. We will see this in a bit. And after we have generated all the synthetic data that we need, we can train our model using Tau. And we can get a few real images to understand if our model is working fine. This is the final objective. So basically, as you can see, this is how our camera is identifying that we have a pallet jack here, or here and here. Okay, so this is the final objective, to understand if our robot or our camera is seeing these pallet jacks around. So let's go and download this repository. I have already created a folder to copy this repository. Okay. I'm going to add this as the main folder. Perfect. And then we have to open this this file. Please understand that Omniverse is based in Ubuntu, and this repository is guessing that we are going to use Ubuntu. I will be sharing as well the commands for Ubuntu, but right now we are going to do the test in Windows machine. So now we are going to see what we have to modify in this file to make it work in our Windows machine. But for Ubuntu will be even easier. So let's go and modify this file. I'm going to keep the original one. So I'm going just to duplicate the file, rename it. Just need to change the extension to bat because we are executing this file in a Windows machine. And let's see what I have changed. First, I add the echo off, so we keep our terminal clean. Then we set our Isaacson path. So this is where I have installed Isaacson. Then we open the directory where we want to create new folders where we will be saving our synthetic data generated. So I'm opening this folder here. Here we will be creating three new folders to save all the synthetic data that we want to generate. We need to modify this to this. So basically we are creating new variables with the direction first. The script path is the script that we are going to execute to generate all this synthetic data, and then this output is the folders where we will be saving the synthetic data that we are going to generate. By the way, I use this dash D because that will allow me to change from one unit to another one, from C to D. But if your direction, if your path is in the same unit, you don't need to add this dash D. Yeah. What else? Okay, here we use the same. You need to add the dash D as well here, and we change again to the path of our Isaacson directory. We don't need to put this in brackets. And finally, we need to change this for this. Here, what is happening is that we are using Python to execute this script, and then we are adding some entry parameters. Okay, we are using the in which area we want to randomize our objects. We can tell how many random stuff we want to execute. So this will be generating 2000 files, one with each of them with different destructors. We are going to generate three types of folders. So we will be executing uh, this script 3 times. One time we will be using destructors, the normal ones that we will be having in our warehouse. Then we will generating another set with additional destructors, and we will be also running a randomizer without any destructor. So we'll be generating 3 different sets of data, each of them with 2000. Well, in total we will have 5000 different situations. And okay, I'm going to save this file. So now, one thing I couldn't solve in Windows, so in Ubuntu, executing this is working fine, but in Windows, I was not able to do this, and please let me know if you find a solution for that. The problem I had is if I run this generate data but once I finish the first set of data, once I execute this script, it will not continue with the second one. So once I finish the first one, it will stop. It's something to do with that we are opening ISACSIM and then we are closing the application and then we need to restart and call again ISACSIM, but it's not happening. So I was not able to fix that. I tried, but I have so much, I don't have too much time for that. So my temporary solution is been to create 3 different files. I'm going to copy this. Rename. I'm going to call this warehouse. Rename. Additional. Rename. So we will be executing this file 3 times. Once is with warehouse and removing these 2 calls. Save the file. That one is none. Save the file, and with additional destructors, save the file. And now before we execute this file, let's go and have a look to the script that we're going to be calling, which is not that one, that one. Okay, so let's review quickly this script. First, we are setting up the command line options that we will be using to configure this script. Here we are adding all the arguments that we are passing here. I think before I said something like the height and width is the area where we are going to randomize the items. That's not true. Apologies. This is for the resolution. So we have the number of frames, which are the number of images that we want to generate. Then we set up the type of destructor that we want to add, for warehouse, additional or none. Then we pass as an argument the directory where we want to save the results of our data generation. This is to launch the simulation. This is to generate our use the file in our stage. Okay, this is where we are getting all the assets that we're going to be using in our script. Okay, we're importing all these assets from these addresses. This is for the labeling and to create the classes for the labeling, like to identify what is a pallet jack. In this case is what we are interested. Then here we are getting all the assets in function of the structure type that we have selected. Okay, this is the same. This is the function that we use to randomize and use the extension of Replicator in Omniverse. And this is the main where all the magic happens. First, we are initializing the environment, adding all the items that we are going to use and loading the stage. Then, okay, this is, so as it says, to check if we have any updates for the extensions and our application. Here we save in these variables the list of items that we want to randomize. Here we are only interested in what is a pallet jack here. From these assets that we're importing, we can see that we have 3 different types of pallet jacks. I don't want to waste time looking for them, but we have 3 and a bunch of items and a bunch of textures. Here is what I wanted to show you. We are creating a camera, and this camera will be always looking at the center of the stage, and we are randomizing the positions of the camera between these coordinates. And then we are adding different colors for our pallet jacks. Then we are randomizing the position and sizes. We are not changing the size, the scale of the pallet jacks. They will stay the same. But basically, in the documentation that I shared, you can see all these small bits of code and what you can randomize and how do we use it. Here we are randomizing the floor and the wall for different backgrounds. Here we are writing the registry, so basically we are exporting all the data of the position of the pallet jacks in Kitty format. We'll have a look at what is the Kitty format in a bit. And well, feel free to have a look. You can copy paste the whole code in ChatGPT and it will explain very well for you if you're interested. But now let's go in and execute our script. Let's go for the fun. Okay, let's get the synthetic data. First one, I'm going to execute the one for the warehouse. So the normal one. Oh my God. Okay, is it's in local. Okay, this will take some time. Now we are opening it is opening automatically a new instance of Isaac Sim. It's loading the stage. In the meantime, just a quick reminder, we're going to generate some files in Kitty format, which is a popular format for computer vision tags. And basically these files are a bunch of numbers. You can have a look at this documentation. But we are setting up labels for the items we are interested in this case, pallet jacks. And we use this format to train our model later on. So right now, the only thing we are doing is generating synthetic data. Let's have a look. You see, we are using all the items within the stage and we are just moving them around, changing textures, colors, even we are using different cameras. So that will be representing what the robot is seeing. Let's have a look what is happening in our VS Code. So now we have created a new folder here called Destructors Warehouse. And we have another folder, camera, and we have it's generating different images. One to identify the depths, another one for instance segmentation, object detection, RGB, semantic. I can't remember which one is the Kitty format. All these are okay. This is for to identify the depths. Then this one is for instance segmentation. Not very clear these images. I'm not sure how attacks him interpret this. Let's see. That one. These are the Kitty formats. Okay. So as you see, we have the label, which is pallet jack, and you have a bunch of numbers that Kitty understand. And then this is the real photos that we are taking. So we will be doing 2000 of this. And you can imagine, the more you do, the more accurate will be your model. Let's have a look at this. So once this finishes, Isaac Sim will close automatically, and that terminal will be closed as well. So not the terminal, but the action. After that, I will be calling these two other bat files with additional elements and with none. I will be back when I'm executing the none one, because you will see that we are only seeing the pallet jacks, which are the items that we want to identify and put labels on them. So let's skip the time. Okay, so now we have generated already two sets of synthetic data, one for the basic elements of the warehouse, another one with additional destructors, and now finally we are going to generate one without destructors at all. So here we will be generating synthetic data only with the pallet racks without any more assets, only the warehouse itself, only its environment. We will be randomizing the floor and walls and the color of the pallet racks. And this will be the third and last set of synthetic data that we're going to create. And this will be all for the lesson of today, because the objective was just to learn how do we generate synthetic data. And in another video in the future, we will learn how do we use this synthetic data to train our model. And in another video, how do we implement this trained model into our robot in Omniverse. I will be showing the next slide how we are going to train our model. So what are the basic elements that we will need to train our model? And then that will be all for today. I'm going to skip the time. Well, you can see also, if we go back to our VS Code, you can see how we are generating all these images. A lot of useful data. So just to finalize, I want to tell you in advance that to train our model, we will be using Tau Toolkit, which it enables to train our model. To do that, we use pre-trained models. Then it allows us to feed the model with our synthetic data. So then we fine-tune our model, and it allows us also to optimize. To be able to use Tau Toolkit, we need to have our format in Kitty format. That's what we did. So that's what we have, and we will be using that. And we need to choose a model architecture. In our case, we will be using DetectNet version 2. And this model architecture is based on residual networks. You can do the search for this, but I'm not going to share these links in the description because I will share them when we create the video to train our model. That will be a good one. So that's all. Thank you for watching. I hope that was helpful, and see you in the next video.